Hello friends and welcome to Comprehensive Tutorials. So from the C++ website we are done with classes 1. We are on the classes 2 tab. And so for that I opened a new file so that we handle those ones separately. Now as usual we have our include iOS stream line over here. And we have this line which is specific for this environment to allow me to create several source files over here. That's if you are using code blocks, you understand what I'm saying. And we have the using std namespace std here to allow us to use the cout and then the cin, and we have these constants over here, nl to denote a new line and t to denote a tab. Now I will be running this program, the entire code that I will be running from void classes2 function. Yours is going to be int main function most probably, and so that's not going to be a problem. So yours is going to be something like this, right? So your int main function over here is my void classes2 function. This is because of the environment, so that's why I have this over here. But when you run the code I'll be writing here, right, if you write it here, we're going to have the same results. Apart from that, there's no other problem. So write every code I'll be putting here inside int main, and then every code I'll be putting outside here, outside of your int main function, on top of it over here. Right, so with that said, let's get to it. So today's video will be looking at operator overloading in classes. Now, so for you guys to see the importance of this particular concept, operator overloading, let's look at this example. So if I have int a, so I have an integer int a is equal to, let's say, 6, and then I have int b is equal to 7, and then I create an int result to store the result of these two integers, right? Then I say that, okay, let's put the result of a plus b into this variable called result, right? So a plus b, and this is going to return an integer result. Then we can go ahead and cout result, right? Right, so we know this already. Now the operator addition here is defined for the class integers, is defined for the class floats, is defined for the class doubles, is defined for the class strings, but just that in strings the output is quite not as mathematical as it should be, but I hope you get what I'm saying. So the operator here has been overloaded to perform different functions in different classes, right? So we can see, to get the picture well, let me say that now I think in the previous video we had, let's say, product shipment 1, shipment 2, right? Let's say that we want to add shipment 1 to shipment 2. What does that mean? The computer will not understand that because it is not, the class product is not a default class, so it doesn't know what the operator addition is supposed to do for those particular class objects, right? So the operator overloading allows us to add more functionality to an already existing operator. I think it's enough of the talking. Let's get to it, and I believe that at the end of the example you'll get what I'm saying, right? So I think I should just leave this over here as a reference, because we'll be using that as a point of reference to see where we are and where we are going, right? So to do this, I would want to create vectors. Now let me say this first before we start the example. So let's say that we have a class called vector, right? Vector, and we create an object called vector a, and then depending on it, so we put in 2, 3 here, let's say 2, 5, right? Then we create another vector b, and we want to call this 4, 5, right? Let's say 4, 7, just to be different. Then we create an integer, we create a variable to store this particular computation. So it's going to store a vector object computation. So we use the vector over here. Over here we're storing integers, so we used integers because a and b were integers. But over here we are performing computation. We will be performing computation on vector object, so we would be using the vector class over here. Then we come down and say that the result is going to be a plus b. Now, what is this going to do? The computer in the first place does not have any class called vector, so this operator will not make any sense to it. Let's run this to see if we'll have any compile time error. And right, we have over here that vector was not declared. So let's even say that we've defined our class called vector. If we still use this operator without overloading it, it's not going to do anything. The computer will not understand it, right? So then let's go ahead and illustrate with an example. So we'll be creating a class called vector to allow us to create a vector object, so that we would overcome this hurdle that vector is not allowed. So let's come up here and create a class called vector. So we first use the keyword class and then vector. Right, then we open our parenthesis and pass in attributes. Now each vector object, so let me just do this. Now each vector object is to have two components, x component and y component. So we would say that this particular vector, any object, is going to have float x component and then a float y component as well. So we are done with giving its attributes to it. So we can come down here and then say that vector, let's name this to vect1, vect1, and then we have vect2, and we want to have vect1 plus vect2. Great. Let me cut this and go upstairs. Sorry, go up here and paste it. Right, so now we have our class called vector, and each object is to have two component attributes. So this vector object, so let's say that we have, right now we can't use a constructor over here, so we want to build this step by step. So we have created two objects. We have not yet assigned attributes to it. So at this stage, what we can just do is to say that vect1 dot x is equal to, then we assign attributes one after the other. We can say vect1 dot y is equal to that. When we can do the same for vector2. But to make our work easy, we would want to use a constructor to allow us to do that, and we'll be using the member initialization method. And each constructor, a constructor is to have the same name as the vector, or as the class, sorry. So we have vector, the name of the constructor is a vector, and then we have parentheses to tell the computer what this vector is going to be accepted. This constructor is going to be accepted. So it's going to accept a float, let's say float a, and then float b. Then we will not forget our colon, and then we want to say that when you take these attributes at the point of construction, set the x component to be a, and then set the y component to be b. Then after that, we want to have these curly brackets, and we are done. Then we can come down here, and instead of passing them vect1.x, we can just say that this is 3 and 5, and vect2 is 6 and 8 as such. So I'll go ahead and clear this. So now we have our vector object defined because our class is defined as well. So let's go ahead and comment this out, and then I think, okay, let me just comment this one too out as well. Right, and let's go ahead and run this to see if we'll have any compile time error. So I'm running it, and we have a compile time error. It says that this is private. I am very sorry for this. So we have private, and these attributes are all, sorry, we should set them to public. So these attributes are now accessible outside these curly brackets, outside the confines of these curly brackets. So we'll go ahead and run this, and now we have no error. right? We have no compile time error. So we have our vector class working. We can define vector objects and we can give attributes to them. Now we what we want to do is to just add this functionality. Let's say that void components. So this is going to be a method, right? Components. So this is not going to return anything, and it's not going to accept any parameter over here. So all that we want to do is to see out x. So it's going to see out the components of the vector. So I want to see out x and then see out y as well. But to make it look like a vector, I think, okay, let's just run this before. Right, so let's come down here and say that vect1 dot components is now accessible, and we want to have parentheses over there. We run it and we have an error over here. It says that cout is, sorry about that, so I have to use curly brackets over there. Right, so we run this now and now we have 35 over there. So vector1 was 3 and 5, but this is 35. That's not what I want. So I want to just edit this one. I'm very sorry if I'm wasting your time right now, but I just want to build from the basics so we understand what we're doing, because this is quite like a maze. Sorry, I may be wasting your time, right? So we want to edit this to make it look like a real vector, right? Then we'll have a comma over there. And then after that, we'll have, yeah, the y. And after that, I want to close it with a parenthesis, right? I think this will do for it. I don't know if we should add a new line over there, right? So then so this is now the void components. Let's see the new edit. So we are now printing vect1 dot components. Let's see what's going to be returned. Now we have 3, 5 returned, just like a vector, right? So we could have gone ahead to say vect1 is equal to 3, 5, but that would be going so way back. So we get the basics now. We have a class vector, we have its object, and we can print the components. Now what we want to do is to add these vectors, and vector addition is such that if you're adding vector1 to vector2, it's going to add the x components together and the y components together. So 3 plus 6 is going to be, let's say, 9, and 5 plus 8 is going to be 13, right? So the result over here is going to be 13. So let's create our vector. So we'll clear this component over there. So we have two vectors, vect1, vect2. Now we have created an integer, a vector variable to store this result, and we've called it vector result. And then we want to say that result is equal to vect1 plus vect2. Let's see if this will do what we want. So we go ahead and run it. Error. It says that no matching function for call to vector this. Now, have you seen this here? Vector with just parenthesis, empty parenthesis. Now, this object that we have created here is an object of the class vector. And to be able to create an object of the class vector, you need to have the constructor allows us to pass in two components, right? Two components, x and y. So technically, while we were creating this object, at the point of creation, we should have specified these attributes. But we don't have those attributes at that time. We needed to add before we have those attributes. So what do? What can we do to enable us to create an object without passing attributes? Because it doesn't allow us. Now, you might have guessed, so what we can do is to create a constructor that allows us to construct this object without passing in any parameter. So we just come down here and say that the constructor is going to be called vector, of course, and it's not going to accept any parameter, and that's it. We are done. So everything is empty over here because it's not going to accept anything. So let's comment this out to be sure that what we now have here allows us to create this. Remember, constructors have the same names, but what differentiates them is that at the point of object creation, when you pass in we passed in two attributes here, so it's going to get the vector, the constructor that takes two attributes. Over here we are passing no attribute, so it's going to get the constructor that accepts no attributes, and then it construct the object for us. So let's go ahead and run this and see what's going to happen. Now we have nothing returned. We don't have error as well, so now we can create this object, right? Great. Okay, so now let's go ahead and add these vectors together to see if anything is going to be meaningful. Now we have an error. It says that no match for operator. Yeah, so there's no match for this operator here. That means the computer does not understand it. So now we are to the point of this video, this tutorial today. We are going to create an overloaded function we are going to overload this operator. Simple. So how then do we go about it? We have the first way is we can use the non-member format, and that's what we're going to do right now because that's much easier to understand. So what we can do over here is to use the name of the class that we want to link the overloaded operator to, and then we use the operator keyword. Then after that we have the name of the operator, and the operator in our case is just a plus, right? Look at the syntax again. Name of class that we want to link it to, then operator keyword plus the name of the overloaded operator. Then after that we want to have what this operator is going to be accepting. Is it going to accept integers? Is it going to accept strings? Is it going to accept vectors? Right, so it's going to accept vectors. So we want to say that we are going to pass in vector A, and then we will pass in the second object vector B. I hope you're getting the syntax. This is going to accept two vectors. The first one is going to be vector, second one is vector as well. Then we come down and define the functionality. Now when we come down here, what we want to do is to add vector A to vector B. But we know that, so whatever A that will be passed in here, we want to get the A dot the X component, right? And then add it to the A dot Y B dot X component of the second one. So this is, let's say, vector 1, vector 2. So we want to get vector 1 dot X, which is going to be 3, plus vector 2 dot X, which is going to be 6. So these two components will be added. Now the second thing we want to do is to get A dot Y, and we want to add it to B dot Y as well. Right, so we are done with the addition. But then this is going to return a result, and the result is also going to be what? A vector component. So just as we have created a result over here to store this, let's create a vector object over here to store this answer. So let's just say call this the answer. So right now we have no attributes passed, but then it has an X component, has a Y component, but then nothing is assigned. So then we come down here and assign answer.x component to be this particular computation, and we want to assign answer.y to this particular computation as well. Then after that we want to return answer, right? We just want to return answer. Note over here that we used vector, meaning it's going to return something, which is also going to be a vector. Right, so we have overloaded this operator. So then let's come down here and then just use the plus. So when you use the plus, it automatically gets these ones and then does it for us. So let's go ahead and run this to see what's going to happen. Now we have assignment of vector and all of that. Okay, so we'll go ahead and clear these parentheses, and then we run this to see what's going to happen. Right, so we have no error now. We have no compile time error now. So those parentheses were the cause for the error. So when you are creating this object, you don't, even though we'll not be passing any parameters, we should not include these ones, right? So now we can add these, and the result now has components. So let's go ahead and then print out these components. So result.components to see what's going to happen. And before that, we want to also see out the vector one dot components to kind of have a feel of what's going on. So vector 2 dot components. Right. So we run this. Oops, I should have that over there. And now we have the first one was vector 1, which was 3 and 5. Then we printed out vector 2, which was 6 and 8. And we added these components, which is 9 and 13. So we have 3 plus 6, 9, 5 plus 8, 13 as such. Right, so now we've been able to overload this operator using the non-member initialization. Now, before we look at the second way, I would want to quickly make this correction. Now, you can see that we just passed in the vector A and vector B directly. But it's not good practice. From the C++ website, they used a different syntax to do that. So I would want us to go by that because it's safe to do that. And we have looked at passing attributes as constants and all of those. So you can easily review that video. We've looked at the advantages why we do that. So now passing this is not quite safe. So what we can do is we can pass this as a constant vector, and we want to just get the address of this one, and then we want to pass this one to as a constant. So I should have mentioned this example is from the official C++ website, right? So over here, what we are doing is passing these. We are using pointers over here, and we are passing it. We are using addresses over here, and we are passing them as what? Constants. It doesn't add so much functionality. It's just a good practice, and yeah, we have looked at the advantages. So let's go ahead and run this, and we should be getting the same results. Right, and we have the same output as before. Right, this is safer and more advantageous. Right, so then we want to look at the second way of doing this thing. So what you can see that we don't have any link. So this is the end of the class vector. This is the end of the class vector, and this is the overloaded operator over here. Now you can see that there is no link inside this class vector to show that this is kind of linked, except for this one, which shows that this overloaded operator is linked with this class vector. Now to use the member initialization, what I want to do over here is to come down and use the vector keyword over here, sorry, the vector class over here, and link it to the operator, right? So this has been established, this link has been established. Now the next thing we want to do is to just pass in one parameter, or one parameter as such. So we'll just be accepting one object of the class vector. I would explain why in a bit. Then we want to get inside here and say that vector answer is an empty object, and want to assign the x component of that empty object to be x, just x, plus a dot x, because that's the vector we're accepting here is a, so a dot x. Then after that, we want to assign the y component of the answer to be y plus a dot y, a here because we are accepting a over here. Then after that, I want to return an answer. Now the next thing I want to do is to get in here and then establish the link. So this is the overloaded operator. Then I want to get in here and establish the link. So what we can do over here is to use the vector class again, and then want to have the name of the operator, and it's operator plus. Actually, the space here doesn't really matter, so we have operator plus, and then we want to have that it just accepts constant vector, the address of a constant vector. So I want to copy this and paste it in there, and we are done establishing the link. Right, so then how do we use this operator? Now the thing to note here is that this operator over here is now kind of like part of the class vector. So any object here can have access to the operator. So you can have, let's say we have vector 1 over here, so we can have vector 1 dot operator, and we will have to pass in another vector object over here. So let's look at the functionality of this one, how it's different and why it is so. But before then, okay, let's look at this way first before we do any other thing. So then we have that. Now we have vector 1, right? And now, as I've said, this over here can then be accessed by any object of the class vector. So let's come down here and say that vector 1 dot operator, and the operator is plus, right? And then we want to have in parentheses vector 2, and that's going to be the vector this one will be accepting, right? Then after we do this particular computation, we can create, I think we should just store it in result, right? Let's just store it in result so that result, and so we can then come down here and say that result is equal to that, and then we want to say that result.components. Right, so let's go ahead and run this to see what is going to happen, and we can explain further. Right, so now we have 9 and 13 as before, so the components have been added accordingly. Now, why did this accept just one parameter, and why did we have to go through this trouble and all of that? Now, why I use this syntax in the first place is for us to get the idea that this one can then be accessed using the dot operator by any object of the class vector. So over here we accessed it using the dot operator, and we applied it on vector 1, right? So we can even apply vector 2 and then have this operator take in vector 1. It's still going to return the same object, the same answer. And we have 9 and 13 over there. Another thing to note is that when we use the member initialization to do this operator overloading, what it does is we can see over here that we just had x and y passed explicitly. That means that the first object that you are applying the dot operator to, so over here we are applying the dot operator to vector 2. So the components of vector 2 become automatically the x and y, and then vector 1 then becomes a over here. So let's just start from the beginning where we have vector 1 and vector 2. So now vector 1 is the first vector, and so using the dot operator on that one would have its x and y components assigned to x and y, and then over here we are accepting another vector which is going to be vector 2, and that's going to be a dot y, a dot x, and all of that. To get the feel of this, let's go ahead and say that anytime this one is called, let's see out y is equal to, so y see out x is equal to, and we see out what x is, right? And then we come down, I think I should put in a new line over there, and then we want to see out y is equal to, so that we'll know at what stage is which one and all of that. So we have that and y, and we should have a new line over there as well. Let's just clear this space. Right, so that will see out and then I think we should see out, so see out x is equal to that, and a dot x, I think I should have a dot x, and a dot x is equal to whatever a dot x is outputted, and then want to have that. Then we want to come down here, let me just copy this, and whoops, and y dot x, a dot y is a dot y as such. Then we would clear these ones. So now we have vector 1 first, and so vector 2 is second. Let's see the state of these variables over here. So we run this, and we have x is equal to 3, y is equal to 5, and if you observe carefully, you would see that those are the attributes of the vector 1, and a dot x is going to be the first attribute of the vector 2, so 6 and 8 over there accordingly, right? So whatever vector gets passed first assumes the position of x and y over there, right? So we can and if you put in vector 2 over here, the attributes are going to be flipped. You can do that if you want to. Now what if we want to, no, I think we should just do this before we get back to what I want to say. So then we can also just explicitly just say that result is equal to vector 1 plus vector 2. We could have done this first, but I wanted you guys to see the first way of doing it. So let's go ahead and run this, and it's going to basically return the same result, right? So we have the same result over there as well. So you can do this, but the first way gives you a feeling of what is actually going on. Now let's say that we have 3 objects, not just 2. So we are creating a third object for the class vector, and we want to have, let's say, 8 and 9. And then what do we do? Can we add this over here, that vector 1 plus vector 2 plus vector 3? Is it possible? Let's try it. If it doesn't return any error, so we are running this. Great, we don't have any compile time error and everything is going right. So let's see whether this is making sense. So 3 plus 6 is going to be 9, plus 8, that's going to be 17. Is that what was returned? Right, so we have 17 over here, and then we have 5 plus 8, which is 13. 13 plus 9, which is going to be, boom, 22, right? Great, so we have 22 over here returned. So then let's look at the order of execution. So in the first instance, the vector 1 was first, and so the components were 3 and 5. So we could see that over here 3 and 5 were the x and y over here, as we have seen, and then a dot x and a dot y were the components of vector 2 over here as such. Now after this happened, a vector 1 plus vector b would give us 9 and 13. So then x and y became 9 and 13, and then a dot y and a dot x were the components of the third vector over here, which were 8 and 9 as such over there, as you can see over here, right? So that's the order of execution, and the same thing happens if you use non-member initialization, right? So I think that should be it for operator overloading and the classes. Right, so the next thing we'll be looking at is the this keyword. Stay safe.